Hey everyone. I've got both good news and bad news for you. Let's start with the bad news. Unfortunately, we still haven't managed to create a real wormhole. But here's the good news. According to recent studies, wormholes might actually be possible. Because scientists have managed to create wormholes in a controlled environment. Not just that, they were even able to send information through them. And this wasn't just a simple computer simulation. In fact, it suggests that this could be physically possible. A group of scientists used quantum computers to simulate a wormhole. And within that simulation, they managed to keep it stable. Then they did something even more impressive. They sent qubits through the wormhole. Which leads to a very powerful conclusion: wormholes might exist, wormholes might be created, and one day, they might even be used for travel. But before we dive deeper into this experiment, let's take a step back. What exactly is a wormhole? We hear about it all the time. Movies, games, sci-fi stories. Wormholes are like the ultimate shortcut in the universe. Want to travel to another star system? Use a wormhole. Another galaxy? Same thing. Instead of traveling thousands of light years, you take a shortcut through space-time. Sounds amazing, right? There's just one problem. We've never actually proven that wormholes exist. But mathematically, they could. A wormhole is essentially a tunnel connecting two different points in spacetime. If they exist, interstellar travel could take seconds instead of thousands of years. Because the universe is huge. And I mean, incredibly huge. Even with our fastest rockets, just leaving our solar system would take years. Reaching the nearest star system, Alpha Centauri, would take hundreds of years. Even if we could somehow travel at the speed of light, which we currently can't, things still take time. For example, at light speed, it would take about 4 minutes to reach Mars, over 4 hours to reach Neptune, around 2 years to exit the solar system completely, and over 4 years just to reach the nearest star. And if you wanted to go to the center of our galaxy? That would take 26,000 years. So clearly, traditional travel isn't enough. We need shortcuts. And that's where wormholes come in. Wormholes are like tunnels in the fabric of spacetime. They connect distant points directly. But creating one isn't easy. You need extreme gravity, the kind you only find near black holes. Black holes bend spacetime, compressing it into a singularity. But if you could somehow balance that with an opposite force, you might prevent collapse. If you stabilize the structure, you create a tunnel. A shortcut. A wormhole. Imagine spacetime like a sheet of paper. Traveling normally means going from one side to the other. But if you fold the paper, you can connect two distant points instantly. That's the basic idea. But remember, spacetime isn't actually flat like paper. You're not punching holes in the universe. You're bending it. The idea of wormholes dates back to 1916, when physicists studying Einstein's theory of relativity began exploring black holes. Later, Einstein and Nathan Rosen expanded this idea into what we now call the Einstein-Rosen bridge. They suggested that black holes might be connected to something else, white holes. And between them, there could be tunnels. But here's the issue. We've never observed a white hole. Because of that, for a long time scientists believed wormholes might not exist. But mathematically, they still made sense. And that kept the idea alive. As quantum physics advanced, scientists began exploring wormholes in new ways. Through equations, simulations, and quantum systems. And interestingly, wormholes kept appearing in the math. Now here's the key ingredient: exotic matter. To keep a wormhole open, you need something very unusual, something with negative energy or negative mass. And that's where things get difficult. Because while it's mathematically possible, we still don't know how to obtain it. So the big question became, even if we create a wormhole, can we send something through it? That's exactly what scientists at MIT wanted to find out. They designed a quantum experiment combining black hole physics with quantum teleportation. They built a system that could run on a quantum computer. In their simulation, they created a wormhole-like structure and attempted to send qubits through it. They used two entangled quantum systems acting like black holes. A qubit was placed on one side. Then negative energy was introduced. This activated the wormhole. And something incredible happened. The qubit went in, and came out on the other side. Information had passed through the wormhole. The experiment worked. Which means wormholes are mathematically possible, they can be simulated, and they can transfer information. So in a way, Einstein and Rosen might have been right. If we can one day create stable wormholes, we might travel across the universe instantly. Maybe even through time. Yes, time travel. The results are exciting. Very promising. But we're not there yet. Because we still have one major problem: exotic matter. Negative mass. We don't know how to create it or control it. But remember, there was a time when black holes were just equations too. And today, we know they're real. So maybe one day, wormholes will be real too. And if that happens, we won't just explore the universe. We'll redefine what's possible. Until then, the question remains. Are we opening a doorway to the stars, or something far more dangerous? We'll have to wait and see. That's it for today. If you enjoyed the video, don't forget to like and subscribe. See you in the next one. Stay curious.